Okay, hello everyone and welcome. In this talk, I will explain HugePages for Postgres, what they are, how to size them, and when they help. And this is pretty much the agenda for this talk. And before we start, a couple words about me. So, as I last calculated, I'm working with Postgres for 14 years already. Now I'm working at a company called Clouds on Mars. I'm also former Microsoft Global Black Belt and the principal program manager for Azure Database for Postgres Flexible Server. And I'm also an organizer of Warsaw Postgres user group, which is inactive for a couple of years now, but I'm going to reactivate it, and in a month we're gonna have another meetup, so I'm really happy about that. The practical part of this talk is mainly focused on Linux-based Postgres deployments. So basically virtual machines and bare metal machines, where you control both operating system and Postgres. If you use any managed services, PaaS services, anyone like RDS, Azure Database for Postgres, okay, not many of you in here, no worries, you can stay. It still will be useful, at least the first part where I will explain what HugePages is and why they help with performance. This is 25 minutes talk, so I will not do deep dive into Linux internals. I will simplify stuff where I can simplify. And most of the examples will assume dedicated Postgres server. So if you run on your machine multiple Postgres instances, or you run Postgres and some memory-heavy applications, the same principles would apply, but the configuration, the sizing would be a bit more complex. So I will be talking mainly about dedicated Postgres servers. Okay, and before actually we start, just quick show of hands. Who has heard about HugePages? Okay, yeah. And who actually has configured HugePages? Okay. Yeah, this is pretty much what I expected, because from my experience, a lot of people have heard about HugePages, but not many of them have really set them up. They sometimes seem a bit too operating system specific or too low level, but actually if you've got huge Postgres instances with really big shared buffers, because shared buffers is the most important part in here, then you can really benefit from enabling HugePages. When I talk HugePages, which is very important, I mean persistent, static, or explicit HugePages. These are configured at the operating system level and then enabled in Postgres and used by Postgres for shared memory. Transparent HugePages, or THP, the second HugePages, are totally different beast. Okay? These are automatic kernel mechanism. We can discuss negatively or positively, in the past it was mostly negatively, but I saw some new benchmark, but they can for sure affect database performance, and they are not configured in Postgres. Okay? So in this talk, when I say HugePages, I mean these persistent HugePages, okay? Not transparent one. To tell you what HugePages are, we need to first connect the Postgres memory with the operating system memory. And I believe that most of you have heard that Postgres uses 8K blocks on disk for storing its table data and index data, right? It was even in one talk before mine. And also is using 8K buffers for the shared buffers. Okay, so 8K here and 8K here. But when actually Postgres starts and allocates these huge chunks of memory we call shared buffers, right? It's not allocating those pages directly from physical RAM. It asks operating system to do so. And there is this structure, in the middle, we call virtual memory. I should probably not go there. Okay, so this thing in the middle, it's called virtual memory in the operating system. And when Postgres starts, it's actually allocating this virtual memory, the operating system memory pages, to back the shared buffers. Okay, so HugePages do not change the buffer size in the shared buffers. They do not change any sizes on the disk. They do change this middle layer that is actually provided by the operating system. Okay, and usually, like by default, these OS memory pages are 4K in size. So we can say that one 8K buffer is backed by 2 operating system pages. Okay, so we've got 1:2 ratio. And this is exactly the layer that HugePages change. Okay, this middle layer. So now let's look what happens between virtual memory that you see on the left and the physical memory on the right. And here, when I say virtual memory, I mean the address space used by the process. It has nothing to do with virtual machine, okay? Even if you've got bare metal machine, you've still got virtual memory. This is the memory abstraction provided by the operating system, and Postgres works, as I said before, with virtual addresses, okay? And the physical RAM works with physical addresses. So to be able to translate one into to another, we need something in the middle that would be our translation layer. And operating system and CPU is doing that for us. So the translations, translation is this particular page in the virtual memory corresponds to this particular page in the physical memory. This translation is stored in the page table, okay? But actually, if we would like to go to the page table for each and every memory access, that would be very expensive. So that's why CPU has this very small cache, very small and very fast cache, called TLB. And this is not transaction. I know that database people would like to say transaction. It's translation look-aside buffer, TLB, okay? Translation look-aside buffer. If the translation is in the TLB, then we've got a hit, and the memory access is fast. If the translation is not in the TLB, then we've got a miss, and we need to go to the page tables and walk it, which is very expensive, okay? So we really would like to have everything in here, in this layer, in the TLB. But if you've got a lot of memory pages, right, it's not easy to fit everything in the small cache, right? And the HugePages reduce the number of the pages, so naturally we've got fewer transactions, but translations to handle, right? So more translation would fit in the TLB. So actually this is what, this is main performance benefit from the HugePages. Okay, so let's make this a bit more concrete with an example. Let's imagine a server, Postgres server with 128 gigabytes of shared buffers. And as I said before, we need, by default, we use 4K pages from the operating system to back those 8K buffers in the shared buffers. If we recalculate, this will be around 33 million of operating system pages. A lot, right? So we need to keep all those translation in our page tables and only the part in the TLB. But when we change the size of this 4K to 2 megs, then suddenly we need 65,000 of them, not 33 million. So the ratio is really huge. So it's 512 times fewer entries, right? So fewer entries means fewer TLB misses and less CPU overhead. Okay, so once again, memory pages larger than the standard 4K base pages and most commonly 2 megabytes. And this 2 megabytes, it's because of the CPU architecture you're using. So probably most of you using Intel or AMD and Intel and AMD CPUs do offer 2 megabytes HugePages. And of course, also not only CPU but also operating system needs to support that. If you use ARM, I believe it's also 2 MB. IBM Power has a bit different sizing, but IBM Power I don't think any one of you is using, right? Like for your systems. What's also important, they do not change anything in Postgres. So they do not change this 8K buffers in the shared buffers. It's working only on the operating system. And it's operating system feature, not Postgres specific feature. Postgres for sure benefit from it, performance-wise, but you just enable that in Postgres and actually configure in operating system, okay? Yeah, so as summary, what HugePages are giving us, they for sure reduce CPU overhead because we've got less page table misses, we hit more frequently in the TLB, and also what's very interesting, HugePages are reserved in Linux. It means that they cannot be swapped. So under memory pressure, like your normal shared buffer can swap. Okay, if you've got really huge memory pressure. But if they are on HugePages, they will not swap. So it's another benefit we've got out of HugePages. Okay, any question to this part before I go to the configuration? Yeah?
Yeah, actually, what is the bad path? So it's getting more memory fragmentation. Why is not enabled by default? It's getting more memory fragmentation. What is the
you know, it would need to be enabled by default in Linux, right? And not Postgres, right?
Yeah, again, why it's not by default enabled by Linux? So, you should enable it for certain basically workload, right? Like you say, for big workload.
Exactly, with big shared buffers, yes, yes.
Try enabling for smaller workload, what will be the impact? Let's say, what is the backup on it? Because if I always small TLB, it looks like everything.
If you small, sorry?
If you have like this translation table, like if it's always small, it's good. So, but if you are enabling it for some reason, and I mean, if it's always small, it's good to enable by default. So I think there is a bad part also to not enable for certain workloads.
Okay. So the question is more, why not enable that for everything, right? Because it's gonna be. That's actually a good question. It's probably the main reason now. It's because you need to do some work to enable that, right? Yeah. You know, I will show you also the benchmarks I've done. This is benchmark actually on my laptop that has 32. Gigs of RAM and 8 cores, and it's actually showing you've got lower performance with HugePages on this server. In theory, you are right. I'm kind of the person that would like to check it and check all the system metrics before enabling also on the small one if really nothing like would change. Okay?
Small ones, I think, like usually in virtual memory, like the operating system is overcommitting and usually it's much bigger than having your physical RAM. Diagrams look like page RAM to RAM things inside.
Oh, it's simplified. You know, it's more to, and overcommitting. It's like totally different thing. Let's say, and the shared memory is also a bit different piece than the, the work mem and the private memory on the server. So yeah. Someone else? Oh yeah. Sorry, I need.
Does it increase the memory usage? Because you increasing the block size, you increasing the memory usage of the PostgreSQL?
No. So like the amount, that's very good point. So not sure if this is okay. So actually, we don't change the size of the shared buffers, right? Like size of the shared buffer stays the same. So if we had 128 gigs of shared buffers, it will be still 128 of shared buffers, but the structure that that is backed by that, that's like backbone of this, will change its size. So it will not be 4K, but it's gonna be 2 megs. So it's gonna be backed by smaller number of pages. That's the trick. So actually will not increase the memory usage. I'm not sure if that's...
Okay.
Yeah?
Shared buffer doesn't shrink or grow after closing it started. There's a configuration section for the size that you should reallocate when it starts.
Yeah. I'm thinking about a metaphor maybe, but nothing comes to my head here. Yeah, no, not now. Yeah, Bruce, you had a question?
As I understand it, you're gonna get to this in the next section, which is what I was gonna wait for. But I think once you reserve free HugePages, you're using resources whether you allocate them or not. So you can't just sort of willy-nilly just say free HugePage everything, because you do have to actually set how much you want to reserve.
Exactly. You must
It's actually
say
a resource.
Exactly.
It's not a free thing that you can just.
It's definitely not. It's very risky actually to set it too low or too high.
Too high, yeah, because it's going to consume a huge amount. And then if you go to the transparent one, which is dynamic, then has a whole bunch of other problems. So this is a very dangerous area to play in.
It is. You need to be very careful. I will say a bit, let's see if the time allows, but as Bruce said, yes, like undersizing and oversizing is super dangerous, can be super dangerous because both actually lead to wasting memory on the server. Okay, so what you should do to set HugePages in your system, in your Linux system. If some of you are on pass, so you just need to enable that and that's all. But for those of you who are not, then set all the parameters you want to set for Postgres first. Like not all of them will change the size of the shared memory needed for this instance. The biggest chunk is always shared buffers, but there are some other parameters that also influence the shared memory size needed for Postgres. So like instead of just, doing the list and checking one by one, just set all that you need, okay, and then start configuring HugePages. The step 2 is mainly here for completeness, because nowadays, like probably all the servers have that, have HugePages support in the kernel. So, but in case, very super rare case that your machine would not, then you've got the commands to verify that. Okay, and now what we need to do is check what size you have on your system. So this was CPU and operating system. So CPU needs to provide the size and operating system needs to support it, right? So you are doing a simple grep from proxmem info and you will see it. I believe 99% chances you will see that, so 2 megabytes, okay? And use the matching Postgres binary, which is the next step. I believe you hit that problem before because it's it happens pretty often in Postgres, right? Especially when you're doing pgdump, right? And you've got your Postgres instance in version 17 or 18, and you're trying to use binary from 14 or 13, right? Then it will fail. The same is here. You need to have like your binary, so Postgres binary in the right version. But in opposite to the pgdump, because pgdump will print you out nice error, so you know it's a bad version, this one will print you really weird errors, which looks like you would have something wrong with your Postgres configuration file, which is actually wrong. It's just you are using wrong binary. Okay, another important step. You need to stop Postgres. This will not work on an active Postgres instance. Otherwise, you will see this beautiful error, another one. And also, you need to switch to your Postgres user or whatever user is owning your Postgres instance. It will not run as root because of security reasons, so you need to switch to the right user. And then finally, you can ask how many pages you need for your Postgres instance. And this is pretty simple. Like the first one, I'm using Fedora, so this is from Fedora. You're doing Postgres -d, giving your PG data directory, and the command is -c shared memory size in HugePages. And you, as a result, just get the number, which is 75 in here. With Debian-like system, who's using Debian? Oh, come on. Okay. Yeah, okay, so let's look like in here, because Ubuntu Debians are doing this thing that they put like your configuration file somewhere else than your PG data, so the things getting a bit more complex. So in this case, instead of -d PG data, you need to give config file location, and in config file you would usually have also, you will also have PG data location specified, so you can omit this -d thing, okay? And now we know we need 75 HugePages for our instance, right? So we want to set it in the operating system. There's a couple ways of doing that, and for sure you need to do it in a persistent way, so it will not disappear after reboot. And my favorite way is actually to create a new file, like, this is kind of popular name, and just put like this 75 number to the etc sysctl.d, right, directory, and then sysctl -- system to reload all the configuration. And you might hit a problem here, because for allocating HugePages, we need contiguous, if I'm saying that right, RAM on your server. So if your server is active from some time, you might not get like the continuous memory to allocate your HugePages. Then you need to restart your server after you set this value in your config, okay? Because when server will start again, we'll see that at the beginning, and we'll be able to allocate this fresh memory. Okay, so we are done with this part, and remember, Postgres is still stopped. And what we need to do, because we've got everything from the operating system side done, now we need to enable HugePages in Postgres. You can do that by setting the HugePages to on in PostgreSconf. There's also this try thing, which I don't believe you should use, to be very honest, because as we said before, like if you use try and you will set HugePages too small or too big, you might not really notice. So it's much safer to do on, because in case like you would put wrong number in this conf file, then Postgres will simply not start, and you will know immediately like it's wrong, right? If you put try, you will not know like what's happening. So you might end up in wasting a lot of memory on your system. But if with on, HugePages on, Postgres will start successfully, then it means it's everything fine. And sorry for the ugly slide, like, Notebook LLM was not able like to generate this one because of this complex math. It's in here like 75 minus 65 was too complex math for the Notebook LLM. So it looks like this. So basically, even if you've got HugePages on, you still should check in prods meminfo if the HugePages were allocated correctly by using this grep. Okay, grab HugePages from prods meminfo, and you will see HugePages total, so how many HugePages you actually set up in this conf file. How many are free? So you need to do total minus free, so you will know how many of them are allocated now. So 10 in this case. And 65, yeah, we've got 3. Oh, thank you. Not reserves. Okay, so this one actually looks as very close fit. And yeah, this is another cool thing that Notebook LLM was able to do, and this time did it really cool because it's just kind of summary of all these steps, right? Like in really nice graphical format, right? So this is pretty cool. And I wanted to show you this benchmark results, but I'm not sure if still have time for that. Okay. 7 minutes? Okay, thank you. Okay, that's cool. Okay, so. Okay, yeah, I need to finish then it works this time. Okay, hopefully it will not get broken. So I did those benchmarks, and just to quickly show you at the beginning, like the machine I was testing on has 32 gigabytes of RAM and 8 cores, so it's not especially huge, but I've done it using an internal tool for benchmarking to eliminate all the systematic errors that PG Bench can introduce. And actually each run took over 9 days because each run is 30 minutes, 3 times, I repeat that 3 times and take the average of each run. So it's basically the whole thing took over 9 days. And you can see, like, let's compare TPS. So more TPSs, the better, right? So with HugePages off, you see, like, the performance isn't really better on this machine. You've got shared buffer sizes in here. So we go from 5 gigs up to 25 gigs. And it's actually going really down in here. I believe I've got, like, the cool, like, this is the -7. So it kind of can be a noise because I was trying to eliminate all the systematic errors, but you know, it always can happen. But yeah, the important thing in here is for small shared buffer, small machine, this not necessarily helps, okay? So it takes you some time to configure, but not necessarily helps with small servers, okay? Okay, what I've got next, yeah, so final takeaways. So if you've got the HugePages already set, any change to parameters, especially shared buffers, but also, for instance, max connections, the list is pretty long, requires you to recalculate actually the HugePages needed for your server, right? Because all the parameters that might affect the size of shared memory you need, if you change them, you need to resize HugePages. And both undersizing and oversizing the HugePages is very dangerous because if you've got HugePages in Postgres, the settings in Postgres for try, and you would go, for instance, with lower number, then this memory will be reserved by Linux, by the operating system, but it will not be used by your Postgres. It will not be used for shared buffers. It will not be used for work mem or whatever. It will be just wasted in there. Yeah, and if you are on pass, you are luckily, you know, you are just switching like, okay, I want to enable HugePages, and you don't need to care. So it's pretty neat. Okay, thank you. Any questions?
So I was just a little curious, when you're benchmarking, do you take into account like how much of the workload fits in RAM versus workload that spills to disk? Right, so like if the database is small enough that it's 100% in RAM,
yeah, that's
will
why
this make a difference or not?
That's why I do the ranges, you know. Yeah, so you know each actually run, so each benchmark is done like with all those numbers of connections, okay, just 3, so not all those, but also, you know, the set of different different database sizes. So it's not like I'm thinking each time which one will hit, will not hit, but I'm trying like to have the range, so I would have like both cases.
Thanks for the talk. You said that it's not helping so much for smaller databases. I'm wondering what is the threshold there, when it starts to matter?
It's not easy to answer that, to be very honest. And actually, this is also the reason why I'm doing this benchmarking. I'm trying to capture this number. So hopefully, because I've got just one server now with like fixed RAM and fixed CPU, I would like to have bigger machine to have this number. But I was part of a couple of incidents, on production incidents, where the lack of HugePages was a big problem. You usually would see that in the page tables are growing, because you've got in Proxmem info also page tables, and you would see it really growing like so. But if you ask me what was the server on the customer that had the incident, I don't recall now.
Thanks for the talk. So, are there any configuration consideration for using the HugePages on NUMA nodes?
Oh yes, a lot of them. It's really wide. So not sure if we've got even time for that, but definitely this is huge topic. Yeah.
Okay.
At some time I bought like a server with 4 sockets to test this too, but it's not easy.
You didn't do any benchmark for this, or?
No, not yet. The server is old, and I need to get it out and clean up and complex stuff.
Yeah. Also, since we are speaking about the benchmark, so I mean, you have specific load, like you are doing a lot of write or a lot of read.
Oh,
so
yeah,
I mean,
yeah.
I mean, it's your benchmark or some kind of standard benchmark. So if it's yours, can you share the repository just interesting?
This is the most standard benchmark you can imagine, so pgbench. But it's always the problem to balance, like if you want something to do really right and you want to have the results, because I want to have like really solid numbers. That's why my benchmark takes like over 9 days, right? If I would add another workload, then probably I would need to run it again, so it would be 20 days. So it's kind of
It depends on the system you are choosing yourself, so it should be more write-oriented or read-oriented.
So this is a standard TCPB from pgbench.
Okay.
So the most standard I could find.
Okay, I understand. Okay, thanks.
That's actually the methodology